Welcome to Lesson 3 in Learning Unit 4, entitled Characteristic Properties of Smart Textiles and Their Characterization. This lesson is part of the Mooc on Advanced Textiles Manufacturing Industry, prepared in the frame of the Hacktex project. The characterization of the specific properties of the smart textiles is based on specific standards. There is a huge need for standardization in the domain of smart textiles. The lesson will present the currently existing standards used to characterize the processability and performance of smart textile products and materials with integrated functionalities. The lesson is divided into 5 chapters, dealing with terminology, standardized aspects of design and manufacturing, evaluation of performance and evaluation of durability. The last chapter includes standards to be published in the near future. Chapter 1. General Standards for Smart Textiles, Terms and Definitions. The need to develop a common language in the field of smart textiles was recognized by the smart textiles community, as it avoids the risk of misunderstandings. For the moment, there are several standards that define the basic notions related to smart textiles, most relevant being ISO TR 23383 that divides the smart textiles into functionalized textiles, smart textiles products and smart textile systems, with or without energy and communication functions. Chapter 2. Standards for Design and Manufacturing Smart Textiles. Standards for Design and Manufacturing of E-Textiles. IPC 8921 provides the conformance requirements for the electrical or thermal performance of textile fabrics with integrated conductive yarns or wires. The factors determining product durability are washing, water, microbes, mechanical forces, environmental conditions, thermal shock and chemical exposure. IPC 8952 states specific design details, materials, coating of the textile substrate, evaluation of mechanical and electrical properties, thermal management, interconnections and quality assurance for printed electronics on coated or treated textile substrates. IEC TR 63203 250 Part 1 reviews the use cases of conductive snap fasteners applied as electrical connectors for e-textile products available on the market. Standards for Design and Manufacturing of PPE. The field of PPE is heavily regulated. There are standards with general requirements for the design of PPE, standards for protection against heat and flame and standards for PPE with integrated smart textiles. ISO 13688 specifies general performance requirements for protective clothing. ISO 11612 discusses minimum requirements for clothing to protect against heat and flame. ISO 11612 presents tests to determine the extent to which clothing is capable of enduring industrial heat, in terms of general heat performance and heat transmission. CENTR 17620 is the basis for design and manufacturing of PPE with integrated smart textiles for thermal and heat protection. Standards for Performance Evaluation of Smart Textiles. Performance evaluation of conductive textiles, smart textiles, e-textiles, wearables, with electronic components. The characteristics specific to the domain of e-textiles are electrical properties, considered at yarn and fabric level, namely resistance and resistivity, with their reciprocal properties, conductance and conductivity. Electrical resistance, measured in ohms, reflects the opposition exerted by an object when an electrical current passes through it and is expressed as the ratio between the voltage V and the current I. Electrical resistivity RO, measured in ohm meter, expresses how strongly a material with certain dimensional characteristics, cross-sectional area A and length L, resists an electric current. EN 16812 describes the measurement of the linear electrical resistance of conductive tracks, defined as the electrically conductive part of the textile having a length-to-width ratio of minimum 10:1. This definition applies to yarns, printed or coated tracks with conductive properties. The preferred test method is the 4-electrode, 4-wire method, but the 2-electrode, 2-wire method is considered when the first method cannot be applied. The advantage of the first method is that it compensates the contact resistance between the electrodes and the sample. The testing equipment includes a source of DC current, a voltmeter, contacting electrodes, insulating surface for placing the samples. The distance between electrodes is at least 10 times the width of the conductive track. Recommended distance is 50 centimeters. The linear electrical resistance RL is calculated dividing the resistance R to the distance between the electrodes D. Standard EN/IEC 63203, 201 Part 1 considers the following characteristics for the yarns. electrical linear resistance, as defined by ISO 16812, and the fusing current, the level of current that can melt or ignite a conductive yarn. Linear resistance is also determined after the samples with integrated conductive elements are subjected to artificial perspiration, a characteristic called perspiration resistance, and after the samples are washed, defining the detergent resistance. ENIEC 63203-201 Part 2 determines the sheet resistance, including after samples are subjected to artificial perspiration and washing, and the fusing current. Sheet resistance, also known as surface resistance, measures the lateral resistance through a thin square of material. It is calculated multiplying the linear resistance by the ratio between the width and the length of the sample. The standard also determines insulation characteristics. IEC 63203-201, Part 3 specifies a test method for determination of the electrical resistance of conductive fabrics under simulated microclimate in clothing. The microclimate is created using a sweating guarded hotplate, as defined by ISO 11092-2014, that simulates the transfer of heat and moisture through the layers of clothing in dry or wet conditions. The electrical resistance of the samples placed on the guarded sweating hotplate is determined based on the 4 electrodes 4-wire method. Performance evaluation of smart textiles with phase change materials, PCM. CENEN 16806, Part 1 presents the evaluation of the heat storage and heat release capacity and the phase change temperatures of textile fibers, yarns and fabrics containing phase change materials. The test method is applied for pure or micro-encapsulated PCM and determines the enthalpy of fusion and crystallization and phase change temperatures, based on the differential scanning calorimetry method. It measures the difference between the rate of heat flow through the sample and the one through a reference substance and derive it as a function of temperature and/or time. The samples are subjected to a heating-cooling thermal cycle in the range of -20 degrees Celsius to +60 degrees Celsius, at a rate of 5 degrees Celsius per minute and under controlled inert atmosphere. The enthalpy of fusion ΔHF, or of crystallization ΔHC, are calculated based on the graphical representation of the variation of the heat flow rate with time. Performance evaluation of smart textiles with shape memory materials. In the case of smart textiles with shape memory materials, performance evaluation is carried out considering the wrinkle recovery and recovery angle for objective evaluation, and crease retention and flat appearance for subjective evaluation. Flat appearance characterizes surface smoothness after washing and is defined as the ability of recovering an original flat shape from a deformed shape, after stimulation at switch temperature in different media. The following standards can be mentioned. AATCC 66 and ISO 9867 are used to evaluate wrinkle and angle recovery for folded and compressed fabrics. AATCC 88 describes the subjective evaluation of the retention of pressed creases, after several cycles of washing and drying. AATCC 124 determines the smoothness appearance after home laundering procedures. Performance evaluation of smart textiles for protective garments. EN 17673 presents the requirements of EN ISO 13688 and EN ISO 11612 applied to PPE in general, and specific requirements concerning protection against heat and flame. It also discusses electrical safety and functionality of smart electronic components or devices, and evaluation of smart textiles and smart non-textile devices and elements after heat and flame testing. Chapter 4. Standards for evaluating the durability of smart textiles. Washability of e-textiles. One of the main requirements for e-textile products and a reason why they have yet to succeed in entering the markets is washability, the capacity to withstand washing cycles without damage to the electronic circuits, the electrical characteristics, and maintain full functionality of the products, integrity and appearance. The effect of the washing process on the smart products depends on 4 factors: duration of the washing process, mechanical strains, water temperature, and chemistry and biology. Washability is assessed by subjecting the e-textile products to washing cycles, and then the electrical properties are determined and compared to the initial ones. Such tests conclude after how many washes an e-textile product loses its integrity and functions, helping to evaluate its durability. Most common standard for the washing procedure is ISO 6330 textiles. The document defines the types of washing machines, the types of drying procedures, the reference detergents, water characteristics, water hardness, pressure and cold water inlet temperature, Washing and Drying Procedures IEC 63203, 204. Part 1 specifies a household washing durability test method for leisurewear and sportswear e-textile systems with electrically conductive components and sensors to collect the data of the user. Chapter 5. Standards in Development. This part refers to standards currently in development, and as such published only as drafts. CENELEC will release a technical report concerning textiles with integrated electronics and ICT. The standards to be released by IEC will discuss passive electric parts for e-textiles, passive e-textile parts, connectors for e-textile applications, e-textile functional elements, evaluation method for garment-type wearable systems, and sheet resistance of conductive fabrics after abrasion. IPC plans to develop a set of standards in the IPC 8981 series. The standards to be released will discuss requirements for conductive yarns for e-textiles applications, design standard for embroidered e-textiles, qualification and performance specification for printed electronics on coated or treated textiles and e-textiles. This lesson discussed the following aspects related to the standards used for the characterization of smart textiles, standards for terminology. Standards for design and manufacturing, discussing guidelines for smart textile materials and products. Standards for performance evaluation for characteristics significant for the use of smart textiles. Standards referring to durability discuss the evaluation of the influence of external factors on the functionality of a smart product. This section presents the influence of washing on e-textiles. The last section lists standards to be released in the near future.